Welcome back, algebra students, to a Kuta worksheet tutorial. Today I'm doing more properties of exponents. Now, I suggest before you watch this video, make sure you check out properties of exponents video. I'm going to go through this video quickly, assuming that you understand the properties of exponents and you just need like a refresher or you just need to see it done. But I'm not going to really explain it. I'm just going to do it quickly for you. Okay, so check out that video and then let's begin. For number one, if we have parentheses and a power outside, we're essentially distributing this power to both of those x's inside. If there was a coefficient, also we would apply it to the coefficient. But let's go ahead and apply it here. So we'd get x to the negative 8. Power raised to a power, you multiply. So we get x to the negative 12. Now we need to make them positive exponents. So we flip it. We're going to put this in the denominator. So we're going to have x to the 8th power, x to the 12th. The thing is, you can combine these two, okay? Because when you have multiplying exponents with like bases, you add the exponents. So we're going to have x to the 20th power. Now, keep in mind, this is a little tricky because first we multiply the exponents, okay? Negative 2 times 4, negative 8. And then negative 3 times 4, negative 12. And then later on, we're going to add the exponents. If you wanted... First, you could add the exponents and then multiply. It's up to you. I kind of did it a different way. You could have started by going x to the negative 5th because you add the exponents and then raise that and you get x to the negative 20th and then done that. That's probably a better way to go, but it's up to you. All right, so the next one, we're just going to go to number 2 and then we'll skip around after that. We're going to get x to the negative 12 because we multiply exponents times 2x to the 4th. So I'm going to add these exponents first because we have like bases here. And that will give us 2 because there's no other coefficients to multiply, x to the negative 8th. Because it's a negative exponent, we need to make it positive. How do we make it positive? We put it in the denominator, x to the 8th, and there's our answer. Okay, let's go to a tougher one. Number 5 looks tough. We have a lot going on here. What I would do is simplify each side first. Yeah, so right here, I'm going to simplify all those that have an x, okay? And then I have these coefficients that I'm going to multiply, and then I have y's. So I'm going to worry about the top first. Looks like the bottom is pretty much taken care of, so let's simplify the top. I'm going to use red. So I have, well, let me see here. Make my line. Let's use purple for my coefficients. 2 times 4 times 3 is 24. Okay, for my blue, I have x to the second, and x to the first. There's an applied 1. That's a total of x to the 5th. And then I have y to the 8th. In the bottom, I still have 3, and then x to the negative 3, y squared. Okay. Now, this is the tricky part. Anytime you have a negative exponent, what you should do is, what I like to do is I move this. Okay, I know he's going to go up to the opposite side. If he's in the denominator, he's going up to the numerator, numerator to the denominator. So really, this is going to turn into 24, x to the 5th, y to the 8th, x to the 3rd being multiplied there. We moved him. Then we have 3y squared. Okay, and now we're going to cancel and combine terms. So we're going to combine these x's to get x to the 8th. We're going to cancel this 24 to get an 8 in the top and nothing and a 1 in the bottom, which is essentially nothing. And I cancel 2 of these y's with 2 of these y's. Okay, the 2, essentially we're doing 8 minus 2 here to get y to the 6. I just like thinking of it as canceling though. So we cancel 2 of those and we're left with 6 in the top. So y to the 6, and that's our final answer. So a lot going on there, but if you take it step by step, it really kind of breaks it down. Now I'm going to show you another one. There's my warning that I need to pick up the pace. I like to cancel first, actually. If you have the opportunity, you can cancel first. So for example, this is another method to do it. I'm going to cancel 3 of these y's with all 3 of these ones. And then I'm going to cancel this last remaining y with 1 of these. So then I have a 2 there. Okay. With the x's, I'm going to cancel 1 of these, leaving 1 there with this one. And then I think that's it. I canceled all the y's in the bottom. Okay. Oh, And I also can cancel the 3 with the 3. So this is the way where you cancel first and then go from there. So then we're just left with 2y squared over x. So that's kind of a simpler way to do it. So if you can cancel, that makes things a little bit easier too. Here, essentially, anytime you have a 0, you're going to cancel out the 0. It's just 1. So we have x over 2 squared, which is 4. So we have x over 4. That's a simple one there. Okay, more negative exponents. This time, the negative only applies to the m. We're going to cube the 2, and then this is going to be negative 12, and then m to the negative 4, 2. There's all different ways how to do this. Some people like to do m to the negative 4 minus a negative 12. I'm not a big fan of doing that. I think it's easy to get lost. So what I do is anytime I have a negative exponent, I just move it first. So I move this to the top, move this guy to the bottom. Okay? So then what I have is I'm going to go ahead and simplify the 2's. So we have 2, and then I change this to m to the 12th power. And then I have 8 in the bottom because that became the third power is 8. And then this m to the 4th moved to the bottom. So hopefully you can see what happens there. Now I'm going to do some canceling and reducing. So this becomes 2 goes into 8 4 times, and that's 1 for the 2. 2 divided by 2 is 1. 8 divided by 2 is 4. And then I'm going to cancel my m's. So I cancel 4 of these ones with 4 in the top. Okay, the bigger one always wins and gets reduced by the amount of the smaller one. So then we are left with our final answer of m to the 8th power over 4. And that's it. Okay, let's check out the second page real fast and then let's call it a day. So we have x to the 4th, y to the 3rd for number 14. This is all to the 0 power. That's very nice because that just becomes 1. So then we have x to the 4th, y to the 3rd times 1, which is just x to the 4th, y to the 3rd, and that's our final answer. Okay, let's move on to number 16. We have the cancel out this. You don't want that. So we have this whole thing to the negative 3 power. Let's put it in the denominator right away and make it a positive exponent like that. And then the top we have this guy, okay, who stays in the top. So let's distribute this power first. So we have 2yx cubed in the top. In the bottom, we have 2 to the 3rd power, and then y to the 6th. Once we distribute that exponent, power raised to a power, you multiply exponents. So we get 2yx cubed over 8y to the 6th power. I'm going to cancel one of the y's in the bottom, leaving 5 with that y in the top. Reduce this guy to a 4. So my final answer is x cubed over 4y to the 5th. Let's do one more just for fun. Let's do this really big one. Actually, this one's fast. So look, cancel this because it's all raised to the 0 power, so that's 1. 1 over 2h negative 3, j negative 4, k negative 2. This one's pretty easy. All we have to do is we have to move these up and make them positive exponents. So this is going to be h third to the 3rd power, j to the 4th, k to the 2nd over 2, and that's our final answer. Let's take a look at this one real fast. This is probably the toughest one. Okay, so in the top, we're going to get 2pm to the negative 1 raised to the negative 4 times 2m to the negative 1, p to the 3rd. So I'm going to distribute this first in the top. Okay, so I get 2 to the negative 4th, p to the negative 4th, and then m to the positive 4th. Now the parentheses are gone, times 2 to the m negative 1, p to the 3rd power over 2pq squared. Now this is tough because we got to combine a lot of terms here. Okay, so I got those guys to combine, and I got these guys combined. I'm actually not going to flip them first. I'm going to try to combine them in the top by adding the exponents because it's multiplying like bases. So let me erase this over here. Write it down if you need to. Oh, almost out of time. So I have p to the negative 4th times p 3rd. I'm going to get p to the negative 1, and then my m. I'm going to get m cubed. Okay, and then my 2's I can combine also. That's 2 to the 1st power, so I'm going to get 2 to the negative 3rd. So times 2 to the negative 3rd. And then over 2pq squared. Now I'm going to move them. Okay, so I'm going to move this p to the bottom, make it a positive exponent. I'm going to make this 2 to the bottom. So in the top, I have m cubed over 2 p to the first power times p that was already there times q to the second, and then we have that 2 to the third power. So that's really m cubed over 2 to the fourth power times p squared times q squared. And then I just simplify from here, which is 2 to the fourth is 16, m cubed over 16 p squared q squared, and that's it. Hope you enjoyed this video. Thanks for watching. I'll see you next time on Wes Explains Best.